Hey there, and welcome. Today we're diving into a pretty wild idea that everything you see around you, planets, light, the very forces holding atoms together, could all come from just one single thing. It's a theory that's aiming to give us one unified blueprint for the entire cosmos. So let's just start with a huge what if. We're always taught that there are these four fundamental forces in nature, right? But what if they're not separate at all? What if they're just different moods, so to speak, of one single underlying entity? That's the incredibly bold claim of the theory we're exploring today.
So, you might be asking, why do we even need a new theory? Well, to get that, we have to talk about the biggest, most stubborn problem in all of modern physics, the Great Divide. For about a century now, our two best descriptions of the universe have basically refused to talk to each other.
Okay, so on one side, you've got general relativity. It's Einstein's masterpiece, and it works perfectly for describing gravity, planets, galaxies, the really big stuff. On the other side, you've got quantum field theory, which is just amazing at explaining the tiny world of atoms and particles. And here's the kicker. They just don't work together at all. The math clashes, their rules contradict each other. It's a huge mess.
And that right there is where things get interesting. Out of this big conflict comes a bold new proposal, a new contender for a theory of everything. It's called dynamic vacuum field theory, or DVFT for short, and it paints a picture of reality that's, well, totally different from what you might expect.
All right, so what is this DVFT thing anyway? Basically, the core idea is this. The universe isn't built from a whole zoo of different particles and forces. Nope. Instead, it's made of just one thing, a single field that fills up all of space. So everything, a star, the chair you're sitting on, even a thought in your head, it's all just a ripple, a vibration, or a tiny change in this one single field.
Now, get this, because this idea completely flips what we think of as empty space on its head. The vacuum, it's not empty, it's not a void, it's a physical thing, a medium that has properties, like stiffness and energy. So stop thinking of the universe as an empty stage. Instead, picture it as a swimming pool that's filled to the brim with this active, dynamic substance.
Okay, don't let this scare you, but this is the math at the heart of the theory. We are not going to dive deep into the math, don't worry. But what's so cool about this is how simple it is. This one little equation tries to describe the entire field using just two key properties. And we can actually get our heads around those properties with a really simple analogy.
Okay, so let's imagine this vacuum field is like a giant cosmic fabric stretching everywhere. And this fabric only has two settings we care about. First is its amplitude. That's just its density, how thick or thin the fabric is at any point. The second is its phase, and that's just its vibration, how it's twisting or oscillating. And that's it. That's the whole game. DVFT says everything in the universe comes from changes in just those two things.
All right, so we've got our cosmic fabric, and it can get thicker or thinner, and it can vibrate. Just two simple rules. So let's try to build a universe out of that. Where do we start? Well, how about with the two forces you feel every single day, gravity and light?
So, forget what you learned about space-time being bent like a bowling ball on a trampoline. In this theory, gravity is way simpler. A huge object like the Earth doesn't bend space. It just thins out the fabric around it, creating a little dent. And we're not being pulled down by some mysterious force. We're just sliding into that dent. That's gravity.
Okay, so that's gravity, but what about light or electricity? All that good stuff. Well, according to DVFT, that's just the other property of the fabric in action. It's the vibration part. It's an organized wave rippling through the fabric. So a beam of light is literally just a ripple in the vibration of the entire universe. How cool is that? And this is where you can really start to see how elegant this idea is. We've got our two biggest forces, and they just pop out of the two properties of this single field. A change in the fabric's density, its amplitude, gives us gravity. A wave in its vibration, its phase, gives us electromagnetism. They're not separate things at all. They're just the same fabric doing two different tricks. Okay, that's gravity and light. The big famous forces. Easy enough. But what about the really weird stuff? The forces that are locked away deep inside an atom. Let's see how DFT handles those using the very same field. So, you've got the weak force, the thing behind radioactive decay. In this picture, it's just a more complicated fizz, or a very specific kind of hiccup in the fabric's vibration. It's not a smooth wave like light. And get this, the theory says it's exactly these little hiccups that give particles like neutrinos their mass, which, by the way, is a huge puzzle in the standard model of physics. And then there's the big one, the strong force,
the cosmic superglue that holds the nucleus of an atom together. How does that fit in? Well, DVFT says to picture a knot tied into the fabric, a twist that's so tight it creates this incredible tension. And it's that tension, that topological knot, that supposedly glues quarks together inside protons and neutrons, making sure they can never, ever escape.
So let's just step back and look at the whole picture now. Gravity? That's just the density of the fabric changing. Everything else, light, the weak force, the strong force, it's all just different kinds of vibrations in that same fabric. That's it. 4 forces, 1 field. It's just so clean.
Now, unifying all the forces is kind of the holy grail of physics, so that's awesome. But a really great theory doesn't just look pretty, it has to actually solve stuff, real, existing problems. So what's the payoff here? What nagging questions does DVFT actually claim to answer?
Well, according to the paper this is all based on, this one idea, this single framework, might actually solve at least 3 of the biggest head-scratchers in physics.
Okay, so what are they? First, like we mentioned, it gives a real physical reason for why neutrinos have mass. That's a big one. Second, it tackles the whole matter-antimatter problem. You know, the mystery of why we even exist, since the Big Bang should have made equal amounts of matter and antimatter that just wiped each other out. And third, it says it solves something called the strong CP problem, which is a really deep puzzle about why the strong force is so, well, behaved and symmetric, when our best theories say it really doesn't have to be.
All right, let's bring it all home. Let's take one last look at the entire picture this theory paints for us, because it's a journey from a single, simple idea to, well, all of reality.
The whole logic just flows so simply. Step 1, the universe is just one big, dynamic field. Step 2, it only has 2 settings, density and vibration. Step 3, change the density, and bam, you get gravity. Step 4, change the vibration in different ways, and you get, well, everything else, light and both nuclear forces, and the result? A single, unified reality that all comes from the simplest possible starting point. It's pretty amazing.
Now, of course, this is still a proposal. It's a theory that needs to be tested, poked, and prodded by experiments. But you have to admit, it's a beautifully simple and compelling picture, isn't it? It really makes you wonder, could this be it? Could this be the ultimate blueprint of our universe? Where all the magnificent complexity we see around us is just the simple dance of a single cosmic fabric.